5-3. All right. In 5-2, listen, in 5-2, you had to show all 6 parts, correct? In the next lesson, so the remaining part of this chapter, they're going to basically tell you that this is false. That you don't have to show all 6 parts. That there are shortcuts. Now, your textbook likes to do each shortcut one at a time. Our old textbook used to throw them all at you in one day and then just kind of let you like practice and practice and practice. I'm not saying one way is better than the other, but today they only give you one of the 4 shortcuts. So by the time you're done with the chapter, you actually will have 4 of them to choose from, okay? So again, I'm not saying this way is better than the other book or anything like that. It's just a different style. And so sometimes I apologize. You might hear me say something. I'm like, wait a minute, you don't know that shortcut yet. Just because of my brain, they're all up there. And I just have to remember which ones you guys know. So we're probably not going to do both of these exploring just to save us some time. But let's do number 1. And number 1, I want you to draw me a triangle with a side of 2, a side of 3, and a 90-degree angle. Okay? You can draw that triangle anywhere you want on that little grid. Okay, I'm grabbing 2 just because, one, they're kind of close up front here, and theirs are different from each other's. Ready? Well, they're kind of similar. Which, is this one yours? Is that yours? I want some of these ones a little, whoops. I don't trip and kill myself here. They're just kind of similar. Gosh, you guys kind of all drew them the same way. Oh, yours is a little different. Okay, take a look at these 2. One is Ivy's and one is Ben's. So here's Ben's. He has a side of 2. Ivy has a side of 2. This one is a side of 3 and a side of 3. And then do you see the angle? Now yours may be in a different quadrant. It may be rotated, it may be reflected, that sort of thing. But would you agree that these triangles have the same perimeter, have the same area? Would you agree that they're congruent? Okay, so today's lesson is about, well, we only have 3 pieces. I thought we needed 6. As long as you have the right combination of 3, then it is congruent. So what I want to show you, and I'm just going to draw it off to the side here. Okay, everybody look at this. This right here is called included. So this is called the included angle. As long as the angle is physically between the 2 given sides, all of our triangles will work. If the angle is not between them, so please don't write this on your paper. Do you see how the A is not between it? Or this, okay, so I say don't write it. If the A is not what we call included, these triangles will not work. And so in spot 2, 1, if we had more time, like if we were on semesters and we had tons of time, you know, we weren't so pressed because exams are right around the corner. And if it wasn't for COVID, I'd give you all a protractor and I would see if you could draw me a triangle with a 2, so a 2, a 90, and a 3, where the 3 is not right here. I would see if you could get that to work. And what you would find is it wouldn't. This side would be too short. Or, let's say you're like, well then just make it a longer number. Just make it like a 7. It would actually go too far. And it would be not a triangle. It would have this extra, okay? So what I'm telling you is this. This combination right here, side angle side, it only works because the angle is what we call included. Now, there are some other combinations, and this is where you might be thinking where, okay, this combination works. You just told us this one. I'm not going to write it the other way, which they're the same, okay? That one doesn't work. This one does work. And it sort of is like, well, why don't we just look at that one today too? I don't know. It's not in today's lesson. It's in tomorrow's or the next day. So for whatever reason, the book took these different combinations and they split them up over different days. So for instance, what if you have all A's? What if you have all sides? What if you have angle, side angle? Like, what combinations of 3 work and don't work? Okay? That's kind of the question here. So today, they just want you to focus on side angle side. So depending on, I guess, like what we get through tomorrow. I can't imagine a 12-question quiz is going to take you that long. But depending on what we get through tomorrow, I'd like to do the next lesson. But if we don't get to it, whatever. By the end of this week, we just have to finish off this chapter. So by the end of this week, and probably on Tuesday, when we review, I'm just going to throw a whole bunch of triangles at you with all of these rules mixed together, and you're going to have to tell me, oh, that's this rule, or that's that rule, or blah, blah, blah. Or I'm just going to throw a proof at you. Today's proof, you guys can all guess the last answer. Side angle side. You can guess it. What are you going to do on the test when you have about 4 to 5 different rules?
Yeah. It's a 1 in 5 chance.
Yeah. You got a 1 in 5 chance, but we want to know for sure. So that's where it's going to be a little bit more challenging, okay? So, side angle side. If you want to look in the book, we can look in the book, but basically this is just kind of what I would think of. Draw yourself 2 triangles. Maybe rotate them or reflect them or something, but try to draw 2 of the fairly similar triangles. Mark one of your triangles, side, angle, side. I can zoom in just a little there. Side, angle, side. Now the other triangle could be rotated, it could be reflected, it could be translated, but basically if you have the same combination, so I have side, angle, side, angle, side, then the triangles are congruent. This is only going to help you in the proofs and stuff like that. It's just going to make them shorter for us. So that's why I didn't want to put too much emphasis on the proof from Friday. I know it was long and it was just long for Friday. It was a long proof. But you will be able to use these shortcuts, okay? So let's turn to the next page. There's 3 problems and then there's 3 proofs. And I'm not saying we have to do all the proofs. Maybe we should at least do like 2 or something, because you do have 1 tomorrow. So, number 3. They just want to know, are the triangles congruent? Now, here's the issue. So everybody pay close attention to this. You almost have to think of the triangles separate. And some of you are good at visualizing that, and some of you are not. So I'm just going to show you the two triangles separately. There's the two triangles pulled apart, okay? You have a side and an angle, and you have a side and an angle. In order to use this shortcut, we need another side in a very specific place. We cannot have the hypotenuse. If we choose the hypotenuse, that's the swear word. ASS. Okay? You can't choose that one. So, if we can get this side equal, then the triangles are congruent. Is that side equal? Why? Because they're sharing it. If we were to be doing a proof, I can't really say sharing. I have to have a definition, a postulate, a theorem, or a corollary. Corresponding would be angles. Or what do you see when you look in the mirror? It's reflexive. Okay? So this side is what we call reflexive. So right now, I would say yes. Yes, these triangles are congruent, but they're trying to get you ready for the proof. Okay? So take a look at 4. You have side, angle, side. Look at the other one. Angle, side, side. Is the A between them? Is it what we call included? No. So we say no, these are not congruent. Okay, look at number 5. It's hard to see, but these are kind of light, but there's little tick marks here. So again, imagine that you pull these triangles apart. Would you be able to, with some work, would you be able to say that these triangles are equal to each other? Now, the angle might be the hardest part, wouldn't it? Because your brain sees this and says, well, then the other side is 92. Your brain says that. It's a little bit harder to do it in steps. But I would agree with you. I've got a side and an angle. I've got a side and an angle. And again, those two triangles are sharing this piece. So I would agree, yes, this is congruent. In this chapter, everybody listen, in this chapter, substitution is probably not your most commonly used property. There's two really common styles that they give you in this one. Reflexive, because the triangles touch. Or look at this one. Could we use reflexive in this? Do the triangles share an entire piece? Could we use reflexive? No. But what are these two angles? Vertical. So in this chapter, I would probably say either reflexive or vertical are practically used in every single proof. I'm not saying substitution couldn't be used, but it's not nearly as common in this one, okay? So there's 3 proofs left. I say we for sure do 6, and then somebody can just pick on this other side. It really doesn't matter to me. Again, I don't really care. So let's try 6. You know you're supposed to recopy the given, but let's just to save us some time for right now. I mean, personally, I don't care if you guys do that. I don't care if you draw the arrow, kind of thing. But if I was on a real quiz or test for a teacher, I think I would actually take the time, because you wouldn't want them to ding you on one point just because you're being lazy and you don't want to rewrite it. Okay? Now, you know the last line. And you can pretty much guess this one right here. because you only have two choices. Either definition of congruent figures, which means you have to show all 6 parts, or side angle side. So I'm going to go for side angle side because I really don't want to show all the parts. That's 4 out of the 8. I mean, I don't think 50% is great, but you've got 50% of the proof right there. Okay? True. All right, here we go. You'll be able to get more. Ready? You have to show 2 sides and an angle. You don't have to go side, angle, side in the proof. You can go side, side, angle. You can do angle first, then sides. These 2 steps are interchangeable. Okay? So, what do you want to do first?
I'll do the sides.
You want to do the sides?
BCE is congruent to BCA.
Wait, say that again.
BCE.
Okay, if it's a segment, if it's a side, it would only be 2 letters. So,
Okay.
isn't C the midpoint?
Yeah, so BC is congruent to CE.
Correct. Now, I would not mark you down for that, Sadie, but technically, this triangle, the way it's been turned, do you see how BC is second, third?
Yeah.
It should go to EC. Again, as long as you have those 2 combination letters together, I'm not going to mark you down for that kind of stuff. But as a teacher, I'm trying to demonstrate to you the exact proper way. Okay? All right. So Sadie gave you the first one. She gave you this piece is equal to this piece. That's this one. But isn't it also a midpoint of the other segment? So then doesn't that mean this part is equal to this part? So let's just put it like an and symbol here and say AC to DC. And then what do I put over here? Definition of? Whenever you see a vocabulary word, whenever you see a word, it's going to be definition of that. Okay? Because the only way you know what midpoint is because somebody told you. I have no idea when you first learned midpoint, probably somewhere in middle school. Like I think about Grady's in 5th grade. If you said to Grady midpoint, I'm not sure if he would know. But you only know because we've told you the definition. So you say definition of midpoint. You have 2 sides. You have the S and the S. You need the angle between them. So what are these angles right here? They're vertical. Now, please don't just say angle C, because if you just say C, I don't know where it is. That could be any one of 4 different spots. So try to use the letters to say this. Okay? So I'm going to go with BCA and ECD. Do you notice how the C's are in the middle? That's the vertex. Now, if you switch the outer letters, I'll give it to you again. Not the end of the world, but B does go to E. Okay? This is the style of proof that is on the quiz tomorrow. Okay? Yeah. Again, I didn't make the order of the book. I wish I did because then I'd be like really rich because I think Hudsonville spent like $50,000 on this textbook series. And Rockford uses the same book. Like, tons of schools use it, so it's like, I'm sure these people, I don't know how much it costs them to make it, but I'm sure they make pretty good bank, you know? Okay.
Do we do number 7?
Sure.
It's like the same thing.
Okay, let's do 7. Here we go. Again, just trying to save myself a little bit of time here. Now tomorrow, you can guess this because you only know one of the shortcuts. However, by the time the test rolls around, you will have 4 different ones to choose from. So part of my thinking is on Friday and or next week, Tuesday, I'm just going to mix a whole bunch of them together on you and see if you can identify which one it'll be. Okay? So, they give us one side. So it's like, boom, I got one of the two. I don't know which one, but I got one. You know you need one more side and you need an angle. Taylor, what are you thinking? Since you asked, what are you thinking here?
I was just BA and CD, but I don't know how to explain why. I just
Wait, which
know.
one?
Like the lines BA and CD.
Okay, but these lines on each side, there really would not be a justification for these lines.
Yeah, I know, but
So think about those two triangles. And if you were to pull these two triangles apart,
oh, the CA in the middle.
yeah, so you would have this piece would be the same. So then we could say CA is actually congruent, remember, first, right, C to A, then should be A to C. I'm not going to mark you down if you put CA, CA. I'm not going to mark you down for that. But again, I'm trying to demonstrate the proper way to do it. So, and what's my reason? Reflexive. Okay, I've got the two sides. Boom. Look at my picture. I just have this right now, correct? Don't write this. I'm going to try to erase it. If I get this angle, is that going to be the right angle? No. Is this going to be the right angle? So I need this one and I need this one, don't I? So I need this top corner and this bottom corner. So go ahead and do your letters. What's your justification? Yeah. Do you see how they tell you the lines are parallel? If the lines are parallel, it's either going to be corresponding or alternates. Because same side is supplement, so you don't want same side. And so these happen to be alternate interior. And if you just wrote that, I'd give it to you. It is a theorem, so you're supposed to put the T in the back, but no big deal. Okay? Questions? All right.